Hello, Assalamu alaikum. In today class, uh, I'm starting lecture 2 on electricity A level. In previous class, I told you about the value of current in a conductor. This value of conductor, I drive the formula for the value of conductor. And what was the formula I told you for value of conductor? It was if a cylindrical conductor, it was the formula A, area of conductor, number of charges, and charge of conductor, and multiply by speed of the charges, by which speed by which electrons are moving in a conductor. Now, in first part, I drive this equation for the value of conductor. In today class, I am starting the next part of the electricity. In this part, we will study first the potential difference. What is the potential difference? This is A level, A2 level physics topic, potential difference. In first lecture you see on my channel, the lecture belong to current. Now there is, today I am starting the lecture on the potential difference. What is the potential difference? Simply, according to definition, we say energy transfer per unit charge between 2 points in a circuit is called potential difference. Now, what is the potential difference? Energy transfer. I am drawing here a circuit, okay? You see, this is the circuit. Now, there is a battery, cell, positive terminal, negative terminal, a current moving from positive to negative. Okay? In every circuit, current moving from positive to negative. Now, there is a resistance, okay? There is a resistance by which current is moving, and this current moving from positive to negative terminal. You see here. In this circuit, this battery itself is applying energy or transfer the energy on this resistors. This resistor is connected between 2 points. For example, this is the A point, and this is the first point, initial point, where current entering in the resistance, and the second point is B, where current coming out from the resistance and going towards the negative terminal. When this battery or cell supply the energy or transfer the energy to this resistance between these two position in which resistance is connected. You check here the two position, A position and B position. When energy transfer between these two position on a charge which are moving along the resistance, charge which are moving along the resistance, due to this energy transfer, this energy battery supply or battery given the energy to the resistance. Now this is called the potential difference. When energy transfer between two position, just like here from A to B in a circuit, energy transfer on a charge, this is known as a potential difference. This energy, maybe we say it is work done, or it is energy, or this energy on charge, mean charge is Q. Now the potential difference is called energy transfer between two positions in a circuit on a charge is defined as the potential difference. Now, what is the formula for potential difference? V equal to E upon Q. V equal to E upon Q or W upon Q. W mean work. We can represent energy as work, or because we can say this energy is as a work, or energy is E. Now, this is the formula for potential difference, and this is now what is the potential difference? And energy transfer on a resistance in a circuit or energy transfer between 2 points on a charge or work on a charge between 2 points in a circuit, it is known as a potential difference. And what is the unit? With the help of formula, we can drive the unit easily. Now, what is the unit? The energy unit is joule and charge unit is coulomb. It means joule per coulomb is the unit of potential difference V, volt. And joule per coulomb we also known as volt. When 1 joule of energy transferred to a 1 coulomb charge, when 1 joule of energy transferred to a 1 coulomb charge, it is representing 1 volt. 1 joule of energy, 1 joule of energy transferred 1 coulomb charge to a 1 coulomb charge. 1 joule energy transfer to a 1 coulomb charge is representing as 1 volt. 1 joule of energy transfer on a 1 coulomb charge. It is represented as joule. Now, this is the unit of potential difference. Now, nextly, we study in this class is known as 1 volt. One joule of energy transfer on a 1 coulomb charge forming a 1 volt. Volt is represented by B and joule is represented by J and charge Q is represented by charge unit is represented by C. Now this is the potential. Now what is the power? Nextly we study power. This is the electrical power. Before this you have studied the gravitational word and also forming a power. Now today we will study in this class the what is the electrical power. This is the power, okay? Now the definition is same for both powers, but here the work which is the electrical work, okay? We say a rate of transfer of energy. Simply we say power is the rate of transfer of energy or energy per unit time. Rate of transfer of energy is known as power. Rate of transfer of energy mean energy per unit time. Okay, student. Now, how can we represent the formula? Rate of transfer of energy mean energy per unit time mean power is equal to energy upon time. Power is equal to energy upon time. When we are transferring the energy and ratio of energy with time we are calculating, this is the power. Mean we say rate of energy transfer is known as a power. Now, what is the formula? Power is energy upon time. What is energy? We drive this energy equation with the help of potential difference formula. Now, power is equal to energy upon time, E upon T, or we can say work upon time, or we can, in electrical power, we can drive it by the formula of voltage. Voltage potential difference is work upon a charge, and work is equal to potential into charge. Now we can put this formula, this value of the energy, work into in charge. When we drive the value of work from with the help of potential difference, it is equal to work into charge. Now put this value in power formula. Now when we put this value of work in power formula, we get V into Q upon T. V into Q upon T. And if you study, if you see the previous lecture, you check there I drive the current equation I equal to Q upon Q. I equal to Q upon T. Now here Q upon T we represent as I because I is equal to Q upon T. That's why we can say power is equal to VI. Or we can we can distribute this formula into many others formulas. When we are using the Ohm's law also, we can change this formula into many other formula. This is the dissipation of the power, okay? Now, when you are using the Ohm's law, just like V equal to IR, then we can drive this formula like as power is equal to, at the place of V, when we put IR, we get IR into I, which is equal to I square R. Clear, student? Now, this is the second power equation. Uh, Many power equation we can form with the help of current formula and with the help of uh, Ohm's law, we can derive different power equation in which first is the P equal to VI, second is the P equal to I square R. This is also known as the power dissipation. We can derive in other situation like when we are applying the Ohm's law, we derive many other equation like the P equal to V square over R. This is also power formula. And we derive P equal to VIT also. P equal to VIT. V potential difference, I current and time. We can derive like that. VIT. No, this is the energy formula, okay? We can get this formula, energy formula, with the help of power, okay? How we derive this energy formula VIT? This formula we get with the help of power formula, okay? We know that power is equal to energy upon time. And we derive the power formula VI. Power is equal to VI. If we drive this formula power equal to energy upon time for energy, now we get here energy is equal to power into time. Energy is equal to power into time. When we place the value of power here, P equal to VI, then energy formula becomes VIT. Now this is the energy formula we get with the help of power. Now it is the multiple of voltage, current and time. Now student, and these are the two topics here. Potential difference and power. What is the potential difference? Energy transfer with unit time. Rate of transfer of energy is known as the power, and the formula power is equal to energy upon time. And secondly, the potential difference. What is the potential difference? The rate of transfer of energy or energy transfer with unit time is known as the power. The formula of power is energy upon time. Energy is E, T is time. We can represent formula E by T, W by T. Okay, student? Clear? When anything is not clear, you tell me. I will make separate video for you. Come on the comment site. You tell me about anything which you didn't understand. Now I'm starting the topic resistance. What is the resistance? What is the resistance? In first lecture, I told you about current. Secondly, potential difference. Thirdly, power. Now I'm starting the resistance. What is the resistance? This is a measure of the how difficult it is to for charge carriers to pass through a component. Okay, basically resistance is the opposition in the flow of current in a circuit. Resistance is the opposition of flow of current in a circuit is known as a opposition of a flow of current in a circuit is known as a resistance, or we can say uh, it is a measure of how difficult it is for charge carriers to pass through a component. It is known as a resistance. According to Ohm's law, we can derive the resistance formula V equal to IR is the Ohm's law. And with this equation of Ohm law, we can derive the value of resistance. Resistance equal to potential difference upon current. Mean ratio between potential difference and current is known as a resistance, which is volt per uh, ampere, and volt per ampere is ohm. Resistance equal V upon I according to Ohm's law. Now volt per ampere, and volt per ampere is known as a ohms. Now these are the symbol for the unit. V for voltage, A for ampere, and ohms by this symbol sigma. We represent the ohm resistance by this symbol sigma. Now resistance is equal to V over A, which is equal to uh, when any conductor which is obeying the Ohm's law, mean in which potential difference is directly proportional to current, we can say in this conductor we can drive a graph of the potential difference in current like that. If we keep at the y-axis current and at the x-axis potential difference, then the graph is drawn as its mean current is directly proportional to voltage. Now this graph showing current is when the conductor is ohmic conductor. Okay. Uh, if we change the axis, now there is no effect. Graph is same. If we change the axis for current and voltage, now there is no effect. Graph is same. Both are directly proportional. Mean current increasing, voltage increasing. This is a straight line. Okay. This is a straight line. Now the second is semiconductor. Previously, I told you about the resistance. Resistance is the opposition in the flow of current, and formula for the resistance, potential upon current, or we represent the unit voltage upon A, ampere, equal to ohms. When there is a ohmic conductor, we can draw the graph VI directly proportion. Now there is also VI directly proportion. Now I'm starting here the graph for what is the situation of the graph in semiconductor. When looking at the current voltage graph of the component, you must consider its forward and reverse bias. Forward bias of a diode is the uh, direction in which it will allow current to flow easily past the threshold voltage, which is the smallest voltage needed to allow the current to flow in the direction of the reverse bias. And the resistance of the diode is extremely high, meaning that only a very small current can flow. In semiconductor, what's happens basically, uh, there is a threshold situation form, which is known as a threshold voltage. Now, what's happened? Basically, current, when we apply the voltage on the semiconductor, what's happened? In according to semiconductor structure, what's happened? Basically, if we draw the graph of current and voltage, basically current increasing in the semiconductor, current increasing, forwardly increasing, but voltage is not increasing. What's happened? At a point when currents come, this voltage uh, becomes a threshold voltage and it is increasing extremely at a point. Okay. In semiconductor, this type of graph is basically current is increasing and voltage is not increasing in the structure of the semiconductor, but a point comes where the current form a threshold voltage. In this situation, current and voltage extremely increasing at that point immediately. Now, this is known as a semiconductor graph. In semiconductor graph, basically forward bias and reverse bias situation form. And after that, the graph is forming and threshold voltage form. Current increasing basically, and when current increasing, there is no change form in the voltage, but at a position in semiconductor, what happen? Immediately or extreme voltage increases. This is the threshold voltage. Now this type of graph form. If we change the reference axis, we keep here the voltage and now same graph is formed. Current here, current increasing basically, and there is no effect on the voltage, but a position comes, reverse bias to forward bias. Position comes where the voltage accidentally increasing, immediately increasing. This is known as a threshold voltage, and this type of graph form in the semiconductor. Now, these are the semiconductor graphs. Now, secondly, when the voltage and current both are uh, passing through a semiconductor. Now, what's happened when there is a uh, filament lamp? In filament lamp, how the graph is formed, and what is the type of the graph they are forming in the um, filament lamp. Filament lamp, there is a resistance wire we are using, and when we are using the resistance wire, now what's happened in this resistance wire? Basically, if we draw the graph, voltage and current on the y-axis and voltage on the x-axis, basically current and voltage increasing. But what happens at a point of current and voltage? Accidentally, immediately, voltage and current increasing fastly. And then what's happened? Then again, these are changing. There is a variable situation form in the filament lamp. Filament lamp at some position obeying the Ohm's law, but after that, there is a variable change form in the filament structure when voltage current graph is formed. Basically, some part of the graph showing the ohmic graph like ohms, but in the filament wire, this is happening. The graph variable after a change of the obeying at some point Ohm law, but after that graph becomes variable, not obeying the Ohm's law. You can check this one in between the current and voltage. You check at the negative side of the graph both values of x and y, and at the positive side we check this graph showing that at some part of the current and voltage when passing through them, obeying the Ohm's law, but after that not obeying the Ohm's law. When we change the graph, no same type. When we change the reference axis for voltage and current, no same type of graph is formed. Obeying at some position Ohm's law, but after that not obeying the Ohm's law, it becomes a variable. Voltage increasing extremely. Now this is known as a ohmic graph. Filament graph. Now clear, student, how the filament graphs form. uh, when voltage and current both are in the plummet lamp. Now I'm starting the next topic. Uh, Component contain a length of the metal wire, basically filament lamp containing the wire, okay, which heats up as current increases, increasing therefore resistance of the component increases as current and increases. At low current in the metal wire will not heat up significantly, therefore for very low current, Ohm's law is obeyed. However, as the magnitude of the current increasing, the graph begins to curve due to the increasing resistance. This is happening in the uh, basically filament lamp. Graph obeying the Ohm's law, and in this situation, current and voltage both are directly proportional. But when current increases, the temperature changes and resistance increases. In this condition, the graph becomes variable. When the circuit and filament wire is not obeying the Ohm's law. And a voltmeter can be assumed to have an infinite resistance, meaning no current can flow through them. And a condition comes in which when the resistance is very high, then there is no current flow. When the filament wire becomes very hot. At low current, the filament obeying the Ohm's law, but at high current, it is not obeying there is change in form. Similarly, in semiconductor, basically, because semiconductor is having a part of the forward bias and lower bias. This is the base of the semiconductor. Now, what happened in the semiconductor? Basically, in semiconductor, when current is increasing, basically no effect form on the voltage. But at a position when current increases, voltage immediately or accidentally increasing this type of graph form in semiconductor when we draw the graph between. Now, these are the three graphs which are very important. These are coming in the past paper. Number one, showing the completely obeying the Ohm's law. And number second, the semiconductor in which current increasing basically no effect on the voltage and immediately voltage increasing. This is the semiconductor graph. And what happened in the filament lamp when low current and voltage increasing directly to at low current, but after when the current is increasing, more resistance changing and increasing, the graph changing its shape and the variable curve form when current increasing and higher reach at higher value and temperature of the resistance increasing. Now, filament now is not obeying the Ohm's law. Clear, student? Now, these are the topics which are belong to electricity part 2 of the uh, A2 level class. This is my second lecture. Inshallah, I will, in last lecture, I will tell you more about the electricity and in which I told you how the graph form in the superconductor. Inshallah, in the last part of the lecture, I will finish the electricity. Subscribe my channel and get more videos. If in any topic you are feeling problem, then contact me. And on the comment side, you can comment and tell me about in which topic you are feeling the problem. I will make another video for you. Now, physics A level with Amir Hassan, and I'm online teacher of math, physics, and